Hey everybody, just another session in the dosage calculation series. Today we're going to talk about conversions and converting between systems. Our objectives today is we're going to identify units of measurement in the household and metric systems. We will look at abbreviations for units of measurement and within the two systems. We'll do equivalents for units of volume and weight. We're going to convert one unit of measure to another and work between the two systems, and then convert a quantity measured in household units to its equivalent measured in metric. So before we really get started, I want to bring your attention to the FTCC ADN approved conversion list. This document is located in your ADN student handbook, and it was created as a reference for you to kind of guide you in the most common ones that you would see in your practice and the expectation of what you should know for conversions for unit exams, final, dosage calculation homework. This document is also going to be located in the MDCC area of your Blackboard course as a standalone document. So what I would do is I would go ahead and just pause the video right now and go into your Blackboard course and pull this up so you can use it. Please know that when we do exams, this document, you cannot have it. However, and I don't want you to memorize it. I promise you, once we start working through some problems and you start doing some work, these conversions will become part of your memory bank. So let's start with a couple practice problems. Before we really start doing some math, we always want to ask ourselves, what are we solving for? So what we want to look at is what is it exactly we're going to? And that is going to be teaspoons, okay? And we're doing some equivalency here, so we need to keep that in our mind. So really what we're solving for in this particular problem is teaspoons per day, okay? Now, we'll just put that right there for us to kind of look at. Other important items when we're reading this problem is that we have, the client needs to drink 1 1/2 ounces per day, okay? So now you just need to kind of look at that. So those yellow items are the things that are significant and relevant. All right, so this is the same problem from the other screen. So we're just going to highlight yet again what's significant and relevant. We know that we are solving for teaspoons. We know the client needs to drink 1 1/2 ounces per day, and always pay attention to how we should round. So now we're going to do a little bit of work. We have X is going to equal teaspoon per day. Okay, so now we can start setting up our problem. So I always like to look at what I have on the top and on the bottom because that's really important. And we know that we are solving for teaspoons. So we kind of need that to be there, but we really have to think about what we have in this particular problem. We're given ounces and we have to go to teaspoons. So let's start with what we do know, 1 1/2 ounces per day, and then we'll make sure that day is on the bottom, and that's going to drive the bus for the rest of the problem. So we have 1.5 ounces a day, okay? So we know day is good. We don't have to do anything, but somewhere along the line, we have to get those ounces converted down to teaspoons. So looking and thinking about equivalencies, you would know that 2 tablespoons, and I put a big T for that, sometimes TBS, okay? 2 tablespoons are in 1 ounce. But we don't need tablespoons because we actually need teaspoons. So when you think about that, you know that in a tablespoon, there are 3 teaspoons, okay? So now you can actually set your problem up and do some math. So all we have to do is keep everything across the top on the top and everything on the bottom on the bottom. We have 1.5 multiplied by 2 multiplied by 3. There's no numbers here on the bottom. What you end up with when you multiply all that is 9. So that is going to be our answer, 9 teaspoons. It is a nice, beautiful, even number, so we don't have to round, and that is our final answer. So this problem, let's take a look and see what we need to solve. We are solving for milliliters, okay? Oh, I meant to highlight on that one, not draw a line. So milliliters is what we're solving for, okay, within the order, and we have 0.5 liters. Now I want to draw your attention to this 5% dextrose in water. Please know that you don't need to do anything with that 5% when we're talking about math. That is how the solution is going to come up to you to administer to your patient. We also know that we need to round to a whole number. So let's do our math. We're going to set it up. We are going to solve for milliliters. Okay. And what we have that we know of, okay, is we know we have 0.5 liters, okay? And I'm just going to put a little dash here because we're not solving per dose per day. We're just trying to figure out milliliters. So now we have to convert. And when you're thinking about the metric system, remember that in liters, there is always 1,000 milliliters, okay? And now we don't need the liters, but we do want to keep milliliters. So now we know our setup is correct. And all we have to do is 0.5 times 1,000. And that is going to give us 500 milliliters. So there is our answer. And there is no need to round because it is already in a whole number. Okay, again, we're going to do some conversion in the metric system. So let's find out what we're solving for. And we are solving for volume in liters, okay? And what else is important in this problem? Well, we know we have to go to the 10th, and we know that we have 1,750 milliliters, okay, of normal saline. And we're going to administer that every 12 hours. What's really important is what we've highlighted and marked. So we are solving for liters, and we know that we have 1,750 milliliters, okay? And we know that we have to have liters on top because that's where we need to be. So we have, in a liter, we know that there is 1,000 milliliters. So now all you have to do is divide, and you come up with 1.75 liters. But wait a minute, got to make sure we round, and we're rounding to the 10th. So we need to look at this number, and the 5 tells us that the 10th placeholder needs to go up. So our final answer will be 1.8 liters. All right, so let's take a look at what we're solving for. We are solving for, in this problem, how many milligrams are we going to administer to the client? Okay, so we need milligrams. What do we know? We know that our order is 500 micrograms a day. We also know that this problem requires us to round to the 10th placeholder. So we are solving for milligrams per day, and we know that we have micrograms that is in the order. So we already know we need to do some converting there. So let's start with what we know. We know that day needs to be on the bottom. We need micrograms, milligrams eventually on the top. So let's go ahead and start with 500 micrograms a day. But we don't need day, we need milligrams. So what we're going to do next is we know that there are 1,000 micrograms in a milligram. These can cancel out, and we are left with milligrams per day, which is exactly what we want. So now we can do some math. And what we end up with is 0.5 milligrams. And here's where I want to pause just a little bit. Our answer is already in the 10th placeholder, so we don't need to round, but I do want to take time to bring to your attention is this leading zero. Please remember that when you are writing questions and answering questions, you always lead, but you never follow. So if you have a situation like this where it's starting with a decimal, you have to have a leading zero. Okay, so let's take a look at this problem. We are solving for weight in grams, but our client, our infant, weighs 4.5 kilograms, and that's not uncommon with that patient population. Other common conversions you'll see when it goes with weight is going to be kilograms to pounds and pounds to kilograms. So we got a couple of problems, if not in this series, in a future series, that will do that. We also know that our question or our final answer needs to be a whole number. So we're going to go with what we're solving for, and that is grams. And we know that we have 4.5 kilograms for our client. And in a kilogram is 1,000 grams. Again, anything on the top and bottom that are like items, you can cancel. We know our setup is correct because we're left with grams. And then you will multiply 4.5 times 1,000. And what you will be left with is 4,500 grams. We needed a whole number, and that is already where we are, so that is your final answer. For this question, we know that we are solving for milliliters. That's what we want our final answer to be. And we are given 8 teaspoons, and we're going to have to convert that. So we're taking a household unit of measure, and we're bringing it into milliliters. And that's not uncommon to do those type of things. For example, if your client is ordered a certain unit of measure in milliliters, well, we all don't have milliliter syringes in our house. So when your patient goes home, they may say, well, I have a teaspoon or I have a tablespoon. So what is that going to be? How much should I take? So we know what we need to solve for. We know what we have. We know we're going to a whole number. And we'll just do milliliters because that's what we're solving for. We know that we have 8 teaspoons. Okay. And we also know that we have to convert that from an equivalency. So in a teaspoon, there are 5 milliliters. Now this is one of the things that you are going to need to commit to memory, which is 5 milliliters per teaspoon. We have what we're solving for, and if we multiply 8 by 5, we end up with 40 milliliters, already in a whole number, don't need to round, and we have our final answer. So in this problem, we have a client is to receive 60 milliliters of a medication. How many ounces will the client receive? So we know we are solving for ounces. We have to round to the whole number, and the client has been ordered 60 milliliters. So we know we have 60 mLs. And we know we need ounces on the top. So there are 30 milliliters per ounce. And again, this is one very common conversion that you will want to commit to memory. What we're left with is ounces, and then you can just take 60 divided by 30, and that leaves you with 2 ounces and no rounding. This problem has us solving for tablespoons. We do need to go to the 10th place in this one, and we have 22.5 milliliters. So let's start solving. Tablespoons is typically denoted by a big T or a big T and TBS, so you might see either one of those. We know that we have 22.5 milliliters, okay? And we know that in a tablespoon, okay, there are 15 milliliters. And again, this is another one that you'll want to commit to memory. And as you practice, you'll start to learn these, and they'll be almost instinctual. Now you can do your math. And what you will be left with is 1.5 tablespoons. We don't need to round because we're already in the 10th placeholder, but I want you to know that you can write either 1.5 or 1 1/2. Both of those answers would be acceptable. So for this problem, we're going to be converting weight from one system to another. Now, we typically at home weigh ourselves in pounds, but in the hospital, we want kilograms. And it's vice versa. In the hospital, we weigh in kilograms, and that's how we document. But then the client's going to be like, well, how many pounds is that? So you want to practice a lot of these. Now, one thing I want to let you know, just as a general rule of thumb, and I want you to check yourself when you're doing this. If you're going from pounds to kilograms, your number that you're going to end up with is going to be smaller, okay? If you're going from kilograms to pounds, the number you're going to end with is going to be larger or bigger. So let's look at what we need in the problem. We've got to go to the 10th place, solving for kilograms, and we have a weight in pounds. So we're going to do kilograms. That's what we're solving for. 150 pounds, and you'll see it written this way too. There are always 2.2 pounds per kilogram. So you'll want to memorize that as well and commit that to memory. All you need to do is now divide, and you will be left with 68.18. But remember, we need to go to the 10th placeholder. So we need to look at this number over on the side, and 5 and higher is round up. So now we know our final answer will be 68.2 kilograms. If you have any questions regarding this session on conversions, please make sure you post them in the MDCC discussion forum of your Blackboard course, and have a wonderful day.